Hi everyone, our topic for today is about integration by algebraic substitution. So this method is another techniques of integration wherein the integrand can be simplified using the algebraic substitution. And at the end of this lesson, you should be able to evaluate the given integrals using the appropriate algebraic substitution. So to learn how to evaluate integrals using algebraic substitution, so let's have the following concepts. So by definition, the method of algebraic substitution deals with the integrals of irrational functions or with irrational integrand. The irrational integrand is transformed to one that is rational by substitution of a new variable. So the following is a guide in evaluating integrals by algebraic substitution. Number one, if an integrand contains fractional powers of a variable x, say x raised to 1 over n or the nth root of x, then the integrand can be simplified by the substitution x equals c to the n power, where n here is the least common denominator of the exponents of x. Okay, second, if an integrand involves expression of the form ax plus b quantity raised to m over n, the substitution c equals the nth root of ax plus b will eliminate the radical. Okay, so let's have the following example. So number one, we are asked to evaluate the integral of sine of square root of x dx. So as you can see, because the argument of the sine function is a radical expression, so we make use of the algebraic substitution using this formula: z equals the nth root of x, or x is c to the n power, where n is the index of the radical expression. So in this case, we let z be the square root of x because the index is 2. And then squaring both sides to remove the radical sign, so we get c squared equals x. Then taking the differential of both sides, we get 2z dz equals dx. And then by substitution, since we let the square root of x as z, so sine square root of x is sine c times dx, where dx is 2z dz. So we have this. And then we factor out this constant 2. So this can now be written as z times sine z dz, where this product is product of algebraic and trigonometric function. So because this is product of algebraic and trigonometric function, so we can evaluate this by using integration by parts. So in choosing your u and dv, we follow the acronym LAYATE, where recall that L stands for logarithmic, I for inverse trigonometric, A for algebraic function, T for trigonometric, and E for exponential. And because algebraic is written first before trigonometric function, so we let U be the algebraic function, which is Z, and we let dB be the trigonometric function together with dz. So we have dB equals sine z dz. And then taking the differential of u equals c, so we get du equals dz. And then to find the value of b, we take the integral of both sides of dB equals sine z dz. So integral of dB is b, and integral of sine z dz is negative cosine c. So following the formula of the integration by parts, wherein the integral of u dB is u times b minus the integral of b du, where u is z and b is negative cosine c, so the product is negative z cosine c. So we have this minus the integral of b du, where b is negative cosine z and du is dz. So we have negative cosine z dz. And then by distributive property, we distribute 2 to each of these terms. So we have negative 2z cosine c, and the negative is positive times 2. So we have 2 times the integral of cosine z dz. But recall that the integral of cosine z dz is positive sine z times the constant 2 plus the constant c. But since we know that the given integrand is in terms of x, so the final answer should be in terms of x variable. So to rewrite this, because z is represented as the square root of x, so we can write this in terms of x as negative 2 times z, where c is the square root of x, times cosine c, where c is square root of x, plus 2 sine z, again z is the square root of x, plus the constant c. So therefore, the integral of sine of square root of x dx is negative 2 square root of x cosine square root of x plus 2 times sine of square root of x plus the constant c. Okay, so let's take another example. So suppose we are asked to evaluate the integral of dx over 1 plus the square root of x. So as you can see, because the denominator contains radical sign, so we can make use of the algebraic substitution, wherein we will use c equals the n root of x, or x equals c to the n power, where n is the index of the radical, or sometimes written in fractional exponent form. Okay, so in this case, we let z be the square root of x because your n is 2. And then when you square both sides, we get c squared equals x. And to find the value of dx, we take the differential of both sides. So 2z dz equals dx. Then by substitution, we replace dx by 2z dz all over 1 plus the square root of x, where square root of x is z. So we have 1 plus z. And because 2 is constant, so we factor this out. So we have 2 times the integral of z dz all over z plus 1. But since c over c plus 1 is an improper integral, so we have to divide the numerator z by the denominator c plus 1. So dividing z by z, we get 1 multiplied by c plus 1, we have c plus 1. Then subtract, so this is 0. Then this is negative 1. So this is the quotient 1, and the remainder is negative 1. So therefore, z over z plus 1 can now be written as 1 minus 1 over c plus 1 times dz. Then by distributive property, we distribute 2 to each of these terms. So you have 2 times the integral of dz minus 2 times the integral of dz over z plus 1. And then recall that the integral of dz is z, so you have 2z minus 2 times the integral of dz over c plus 1. But this is of the form du over u, no, where u is z plus 1 and du is dz. So you can write dz over z plus 1 as du over u, where recall that the integral of d over u is the natural log of the absolute value of u plus the constant c, where u is z plus 1. Okay, so in this case, we can rewrite this integral of dz over c plus 1 as the natural log of the absolute value of c plus 1 times negative 2 plus the constant of integration c. But since the value of c is the square root of x, so we can replace this by square root of x. So we have 2 square root of x minus 2 times the natural log of the absolute value of z, where c is the square root of x, plus 1 plus the constant c. So this is the final answer. The integral of dx over 1 plus the square root of x is 2 square root of x minus 2 times the natural log of the absolute value of square root of x plus 1 plus the constant c. So in summary, the irrational expression in the integrand can be transformed to rational expressions by using algebraic substitution.